So we have an awesome new feature today dealing with real-time language learning for our language model. Um, so in particular, what we're looking at is an example model. We do have some training data right here. There's also a lot more basic like system level training data in the base model that you can't see here. In particular, there's a specific line that says, we're going to reference, which is saying like, okay, we're going to create this, walking the user through creating a video, and one of the steps is the user creates, sets the video title. And I intentionally set this up so that the initial training data is looking at, uh, looking for a very specific form of response from the user, which is when the user says the video's title is blah, blah, blah. And what we're trying to do is actually demonstrate Beta AI seeing something slightly differently. And then we already have a resolver. So previous demo I demonstrated like, okay, the AI can understand that. But now we're demonstrating a brand new feature where the AI can in real time derive the new training data that would have resolved that prompt. And I'll do a demo, and then I'll go into the techniques we use to do this, as well as some of the implications of not just how this makes training AI models much faster and easier, but there's some very subtle, very powerful ideas behind this concept. So if we go and demonstrate this, we are going to uh, do an example walkthrough. So demo application. So you say create video in this demonstration, and I'll go through. And I'll expand show in developer mode. So some of the new things is like, okay, we have this resolver, and we're going to see this resolver kick in. Like right now, the resolver's not doing anything. So say, okay, and so there's no training data for this, but there's some very similar training data. So say the title of the video is, I don't know, cloud architecture. So there's some similar training data, and normally you throw this at an LM, and it's like, okay, you hope that maybe the training data you gave it is good enough or not. Well, we're actually establishing, okay, this training data is good enough or not, and then if it is good enough, the resolver is going to put that and then put this back in, so it's more accurate and much faster in the future. So I'm going to run this. It's going to think a bit, and so this means when you see this line, resolve text, it says, okay, that AI understood what it's doing and went forward. But in doing so, it had invoked an LLM, and we're trying to stick to state machines as much as possible that are much more reliable. We don't have to worry about hallucination errors, and it'll much easier to debug. So when it did this, it actually created some brand new training data. If we go back, we refresh this page. So this was just created. So if we look at this prompt, AI generated saying, hey, the title of the video is video title. If we looked at what we said, was the title of the video is cloud architecture. So I understood like, okay, with the training data, what we did is we say, okay, the title of the video is blah, blah, blah. And it understands that there's a parameter called, video title from some previous training data. And it worked out, okay, the new training data needs to look like this. The title of the video is this. So that's that. And so the implications are that this makes it much easier to train a language model. And this is done in real time, as you saw. There was no calling out like it. I think it took a couple seconds to run, very quick. There are some implications if the if your language model gets really large, the way we do it. Real time might be stretching a bit. Like it might take a couple minutes at most. But there's again, we're in the land of traditional computer science, so there's ways of algorithms, and there's caching, and there's like persistent models, all these kinds of tricks that can allow you to get around that. So it's like, okay, you just have what you do is you create, you have a live model, and then when you have a new model, you quickly train that behind the scenes. Takes a couple minutes, and then you now switch. Once that's ready, you put in the new live model. So it's as real time as you can get. Right now, it's actually like if this training data was ready to go. So if the very next message the user could have sent could have used this, and so the implications are that now. Right now, the current language model is what we call an ILM, so intermediary language model. It's a very simple, like kind of prototype code. So it's been a prototype for a while, but now it's getting production ready. The next stage of the ILM is using this, which is actually saying, okay, how do we parse language in a generalized form, where we can generate instructions that describe what the user is trying to do. So there are, this looks like text, but actually this is being parsed. There's a little bit more structure behind the scenes when the model's running, when the AI is running. So saying, okay, we need to split the text into two. So this is a literal match, and then there's a simple match. So this is the simple language model. So it's kind of like a prefix tree with regular expressions, and then when the when there's a match, it can bind instructions, secondary instructions to execute that can define state, saying, hey, when the user's saying this, we think if you see this specific phrase, this might mean that they're being sarcastic. So set a sarcastic flag. Um, Stuff like that, or go and do this action. So when you say, the title of the video is blah blah blah. Now, right now we're storing this, these actions externally, but I am going to bind this in. So the second version, the ILM, is going to actually say, okay, when you see this, say, do this action, let's play a game of baseball. When it sees that, it says, okay, when you see the sentence, let's go play a game of baseball, go play baseball. When you see a sentence, let's go play basketball, the AI says, okay, I'm going to go set up the game of baseball. The user's going to say, no, I meant game that we're going to play is basketball, not baseball. And so the AI is saying, okay, so when I see the let's go play, I'm going to split that off from the next word, which is going to be the subject of what we're doing, basketball, baseball, whatever. And we're allowing this to do this in real time and very quickly. So it's like a very generalized version. This also allows you to do things like, okay, you have one language model, but you can have contradictory context. This is stuff you cannot do with a large language model, which is, okay, you're training and learning. Well, the context might be like, okay, for say you're running a company, one person says, I'll go create a table to do blah, blah, blah. Well, let's say go create a table. They mean, go create an Excel sheet. Or another person in the company with the exact same language model says, well, traditionally they say, go create a table, go set the table, which is, go set like a physical table for like catering, chairs and all that. The language model can actually understand like, okay, there's context between those two, and I understand when to switch back and forth, and it can learn that. But being able to actually parse language, and then we can actually bind instructions. So the big thing that I'm really working towards is this is like hard training. So there's code I'm running that's actually doing these kinds of checks. The kind of real idea of going out this is soft training. So there's some code that catches, okay, there's the resolver, you need to trigger the resolver and all this when you see a specific match. Soft training is, okay, the user says, hey, you didn't do the right thing. The right thing is blah, blah, blah. And so we run this exact same code that says, okay, when I see this prompt, when I see this text, this is how you reparse the text for this person in this situation. And then we pass this off to the core AI, and the core AI is actually making higher level instructions. Like, okay, how do we define instructions? One, it's going through this this prefix tree of parsing text to actually define what the user is trying to do, and it's doing this without having to like actually trigger the code specifically to do that. Because if I knew all the ways to check for when there's a mismatch between the training data and what the user is saying, I wouldn't need to we wouldn't need language models, but here we are. So I hope that understands where we are and where we're going.